Hello, this is Keith from Kinvert, and I'm going to be trying to give you kind of a visual for how this is working when we're solving for equations. Right now we're trying to solve the equation 2x plus 3 equals 9. We've got these two lines drawn here. This first one right here is just the graph of 2x plus 3. And then this upper is just literally the equation of, y equals 9. And so you can see this is passing through 9 if you count 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is just a straight line, y equals 9. And this is the graph of y equals 2x plus 3. And you can see the slope's pretty steep, y-intercept of 3, so hopefully that makes sense. What's going to happen as we solve this? The first step of solving this equation is to get the constant away from x. We're going to subtract 3 from both sides, minus 3, minus 3. We will end up with 2x equals 6. Does that make sense? So let's draw, we know this part. We're just going to draw 6. So 1, 2, 3, 4, 5, 6. We draw straight across here is our new line. What about the other part of the line here? So we have 2x, just 2x. And so that's going to be a line parallel to this, but through the y-intercept. And so let's find a point we know. So if it's 2x, now hopefully maybe you can look at this and know that the solution is 3. At 3, we're going to be here. And at, let's see, at negative 3, we'll be at negative, so if it's 2x, no, it's just 2x. So if it was at negative 3, it'd be at negative 6. Negative 1, 2, 3, 4, 5, 6. So we can draw a line between, that was really jumpy at the bottom, through those 2 points. And this line, sorry that it's drawn so crooked, but this is just the line of 2x. There's no plus 3 anymore, it's just 2x. And this is showing y equals 6. And one thing that you'll notice is that these lines seem to intersect at the same point. So that's kind of an interesting thing to observe. We just did a transformation that left the intersection of the two lines of, the left side versus the right side. They intersect at the same vertical spot here at x equals 3. Now let's do this last step. We have 2x equals 6. To isolate x, we want to get rid of the coefficient. So what we're going to do is divide both sides by 2. And this is going to get us x equals 3, because 2x divided by 2 is just x. 6 divided by 2 is 3. So hopefully you can guess what I'm going to do next. The right side of the equation is 3. 1, 2, 3. I'm going to draw this line across. This is the graph of y equals 3. Now we want to draw the graph of just x. How are we going to do that? So we're going to grab this color. So if we have a x of negative 9, if it's just literally y equals x, we're going to be graphing out y equals x. So at x is negative 9, y is negative 9. So here's negative 9 for y, negative 9 for x. We're going through that point. And if we're at positive, well, it's also going to go through 0. If x is 0, y is 0. And if x is 9, y is also 9. So let's try to draw this out as straight as I can. I've turned on this tool that allows me to draw straight lines. So I'm going to go down to this point here. Is it going to let me? So I guess I'll go here. Then I'm going to go up to this. And I want to make sure that my lines are going through the 2 points that I made at -9, -9, and 9, 9. And now I'm able to draw my line straight. And what we see is, once again, let's go to green here. For the very first equation, 2x plus 3 equals 9. Here is y equals 9. So again, we graph the right side of the equation, that is y equals 9. And then we graph the left side of the equation, and that is 2x plus 3. That's this one, 2x plus 3. And we're getting this line right here. This is the 2x plus 3, this one. And that goes up and it intersects at at x equals 3. Okay, so if you were to graph this, this is the, x equals 3, it intersects there. And then we subtract 3 from both sides, we end up with 2x equals 6. If we graph out the right side of the equation, that is y equals 6, that's going straight across, right? 1, 2, 3, 4, 5, 6, y equals 6. And on the left side, we graph that. We just say y equals 2x. That is this line going up, and it intersects, both of these lines intersect at x equals 3. Okay? And to isolate the coefficient from x, we divide both sides by 2. Now we're left with x equals 3. If we graph the right side, that is this, the y equals 3. And if we graph the left side, the x, this is literally just, it's right here. This is y equals x. And it intersects once again at x equals 3. And that is the solution to our equation. So we did all these changes, and each time we made sure, we didn't make sure, but graphically this is what happened. Every single time that we transformed these equations, they still intersect at x equals 3. X equals 3 is the correct answer. Hopefully you know the steps already of how to do that. If not, go back and check that out. But I wanted to give you a visual guide for what is happening when you're doing all these transformations to the equations. You will still find that every time you do the transformations between these, every time that you do operations on both sides, you still have the intersection of the two equations. One equation is 2x plus 3. The other equation is 9. They intersect there. This equation's 2x, y equals 2x, or y equals 6. They both intersect each other there. Once you get down to x equals 3, they're both intersecting at the same point. So this was Keith from Kinvert. I hope this made sense to you, and I hope it was helpful, and we will see you guys later. Bye.